Welcome to Chapter 12. We are going to split Chapter 12 into two pieces. The first piece is on arithmetic sequences and series, and then we'll test on it. And then we'll move on to Chapter 12, Part 2, which is 12.4, which is on geometric sequences and series. We're going to split it up, and then we're going to end out the year with composite functions, which we'll get into with that little piece of Chapter 9. So first we're going to introduce arithmetic sequences today, looking at explicit and recursive formulas. So the first thing I want to do is get a few definitions down. So an arithmetic sequence, for the starters, is a series of numbers that has a common difference between each of two consecutive terms. So for example, the sequence 1, 3, 5, 7, 9, etc. would be an arithmetic sequence because we add 2 each time. Now, when we talk about an arithmetic sequence, we can use an explicit formula or a recursive formula. The explicit formula is going to be to use to find the nth, or just basically any term of an arithmetic sequence. This is going to be t sub n is equal to t sub 1 plus d times the quantity n minus 1, where t sub n is the last term in the sequence, t sub 1 is the first term, d is your common difference, and n minus 1, or n is going to be your number of terms, so you'd use n minus 1 in the function. Recursive formula, on the other hand, is going to be used to find the next term of an arithmetic sequence using the previous term. So we have t sub 1 equal to some number, which t sub 1 is our first term, and then the second equation would be t sub n is equal to t sub n minus 1 plus d, where t sub n minus 1 is the previous term, t sub n is that term you're looking for, and d is that common difference. So first thing we want to look at is being able to find the common difference and the next term. So here I have a sequence of 1, 4, 7, 10, 13, etc. What we're going to do here is take a look at how we get from t sub 1 to t sub 2 to t sub 3 to t sub 4 to t sub 5, etc., etc., etc. So I see that to get from 1 to 4 is plus 3. From 4 to 7 is also plus 3, 7 to 10 plus 3, 10 to 13 plus 3, which means that my common difference, or d, is 3. Then that means for the next term, I'm going to add 3. Well, 13 plus 3 is going to give us our t sub 6, and that is equal to 16. The second step today is going to be to take a look at a sequence and see if, based upon what I give you, the sequence is arithmetic. And if so, we'll identify the common difference and the next term. In our case here, from negative 4 to negative 8 is minus 4. Negative 8 to negative 12 minus 4. Please always check everything in the information you're given, because sometimes it'll be just that last term that'll change. Negative 12 to negative 16 is minus 4, which means our common difference, yes, this is arithmetic, and our common difference is minus 4. That means if we take and subtract 4, so negative 16 minus 4 gives us negative 20, which is our t sub 5. In part C, 2, 5, 10, 17, I see that to get from 2 to 5 is plus 3. From 5 to 10, though, is plus 5. 10 to 17 is plus 7. And now while what we're adding on is 2 more each time, that does not form a common difference. So this, we would say, is not arithmetic. Example D. We have 7.2 plus 9.7 to 12.2 to 14.7. To get from 7.2 to 9.7, I'm going to add 2.5. If I add 2.5 to 9.7, 9.7 plus 2 is 11.7, plus another 0.5 does give me 12.2. If I add 2.5 here, 12 plus 2 is 14. 0.2 plus 0.5 is 0.7, so plus 2.5. So yes, this is arithmetic. And the common difference is 2.5, and t sub 5, if I add 2.5 on down to 14.7, I get 17.2. The next piece is being able to take a sequence that we tell you is arithmetic, find the explicit formula, and then use that to find terms within the sequence. So here we have 2, 6, 10, 14, etc., all the way up to, say, t sub 50. So if you remember, our explicit formula is t sub n equal to t sub 1 plus d times n minus 1. In our case here, our t sub 1 is 2. And as I look here, 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 4 is 14. That means that my d is 4. We're going to leave the n as n, so we have a variable that we can use this formula over and over again. So now if we substitute in, that tells me that t sub n, which we're trying to find, that's like our y, is equal to t sub 1, which is 2, plus d, which is 4, times n minus 1. Now while you can leave this, I guess, in this form, I'd rather you simplify it. So in our case here, we're going to distribute the 4, which would leave me with 2 plus 4n minus 4. And then we can simplify this. So then that means that t sub n is going to be equal to 4n minus 2. So now I can use this to find the 5th term in the sequence. So that means I'm going to find t sub 5. And t sub 5 means I'm going to take 4 times 5 minus 2. Well, 4 times 5 is 20. 20 minus 2 does give me 18. Now, one of the things you will see right now that is an advantage, if you had left it with this one and simplified, you would have had a lot more simplifying to do. So now I want to find the 50th term, so t sub 50. That means I'm going to take 4 times n, which in our case is 50, minus 2. Well, 4 times 50 is 200, minus 2 gives me 198. The next piece is if I give you the explicit formula, in this case t sub n equal to 40n minus 15, find the first 4 terms of the arithmetic sequence. So that simply means we're going to start plugging and chugging. So I have t sub 1, so that means I'm going to take 40 times 1 minus 15. 40 times 1 is 40, minus 15 gives me 25. I want you to go ahead and find the next 3 and then check to see if you are correct. All right, let's check these. So if I put in 2 now for n, 40 times 2 is 80, minus 15, 80 minus 10 is 70, minus 5 is 65. T sub 3, we now have 40 times 3 minus 15, which is 120 minus 15, which gives me 105. And t sub 4, we have 40 times 4 minus 15, which gives me 160 minus 15, which is 145. The final piece we have here is using the recursive formula to get the 2nd, 3rd, 4th, and 5th terms in this sequence. So we're telling you that t sub 1 is 3. And I have the formula t sub n minus 1 plus 4, which simply means that this, so in this case t sub 2 is going to be equal to t sub 1 plus 4. While t sub 1 is 3, 3 plus 4 gives us 7. So then we do t sub 3, which is equal to t sub 2 plus 4, which t sub 2 we found was 7, so 7 plus 4, which gives us 11. T sub 4 is going to be equal to t sub 3 plus 4, which in our case, t sub 3 was 11, plus 4 gives me 15. And then finally, t sub 5 is equal to t sub 4 plus 4. T sub 4 is 15, plus 4 gives us 19. What I need you to do now is to go ahead and give these 3 U-try problems a shot. And then go ahead and bring your questions with you to class tomorrow.